My name is Griffin Furlong. I'm a professional engineer in the state of Florida, and in today's video, we are going to walk through how to read construction plans. I've been doing this series for a little bit now, and we've already dove into how to read cover sheets, existing condition sheets, site plans, grading, and now we have made our way onto the utility plans. So this video today will be all about a master utility plan. We'll look over what you might expect. We'll look over the key components of a utility plan, as well as things to watch out for if you are in fact creating one of these guys. But I'm ready to jump right into it, so let's get to it. All right, so here I have a master utility plan open, and what I will preface this with is that this is a residential neighborhood. So a residential neighborhood utility plan might look a little bit different than a commercial plan. I will definitely make a video next time on a commercial site. In a master utility plan, let's zoom in to an area. Now, what I'm expecting in a master utility plan is typically a label on where we are connecting to existing utilities. Now, for the very beginners out there, what the heck even is a utility? Utilities are what is provided to either the lot or the commercial building. For instance, every building needs water, sewer, irrigation, and those are typically called wet utilities because there are, water and actual sewage in those pipes. And then you might hear some people say dry utilities. Now, the dry utilities are your power, so all of your electric, your fiber optic cables, like how you get internet, telecom. So again, utilities are the conduits or PVC pipes, DIP pipes that are coming into your property to deliver you your utility. Because if you think about it, if you own this home over here, you are paying for water and sewer service from the utility provider. In this case, it could be a county or a specific utility authority providing you that water and sewer. All these utilities have to come from somewhere, right? So the water is either coming from a water treatment plant of some sort, and the wastewater is typically delivered from our site, capturing all of our waste and being sent back to the wastewater treatment plant for it to get treated and put back, in use. Sometimes it can be used for reclaim if we treat it, and sometimes it's just put back into the environment after it's treated. But back to the focus of the construction plan. So again, usually what we're going to be seeing on a master utility plan is the existing utility connections. So if we look in here, we'll notice that we have some labels: connect to existing 12-inch PVC water main. Looks like we're connecting to an existing 6-inch force main, and then connecting to an existing 12-inch reclaim main. What's also typical on this master utility plan is the material, and sometimes what you might even find is the linear feet of the mains. So we're scrolling along here, and notice how we have all these MHs. So these MHs are the manholes. So we have a wastewater collection system here that is a gravity network. So all of this gravity sanitary sewer is collecting sewage, and it's bringing it all the way down to this lift station. This lift station then collects the wastewater and then pumps it back out from this force main, this 4-inch PVC force main, and pumps it right back out to the existing force main so it can transport all the way back to the wastewater treatment plant. And there's not really much more to it from a master utility perspective. I always like to think of all of this stuff in terms of how a county reviewer would review this set of plans, or even a contractor. We're giving a high-level overview of what we are connecting to and what we're proposing. What are we proposing for this project? Are we proposing an 8-inch line, a 4-inch line, a 6-inch line? What are we proposing here? But let's dive into some of the sheets. Also, I'm going to just take a quick pause here. I've been appreciative of everyone joining in, tuning into all of these different series of reading construction plans and then the land development series. So if you find this content helpful, please hit that like and subscribe. It helps a lot. And let me know in the comments what else you guys would like to learn. I'm getting a lot of questions related to the PE exam and the FE exam, so shoot me some comments below. Now, a really good set of plans always has a strong key map. Now, the key sheet map tells you where you're at in space. So let's say if the contractor wanted to understand the specifics of this entrance over here and how we're laying out the utilities, we're going to direct that contractor to go to sheet 29. So let's go to sheet 29, and I'm sure it'll just be the next sheet. I also love Bluebeam here. We got these nice little tools. You got a little full page here. So that zooms everything out. So let's zoom into what is going on over here in this area. One thing I'll say about utility plans before we dive into this entrance is that it can really appear like there's a lot happening, and I'm sure it is. I'm sure it can get overwhelming. There's a whole bunch of lines going in and out everywhere, but I promise you, the more that you spend your time reviewing these plans, the more that you will get comfortable. And if you keep watching these videos, I promise that you'll start picking up on certain things to look at. The first area that I want to focus on is this water main. So we're connecting a 12-inch water main right here along this entrance road, and then on the other side we have the reclaim and the force main. Now this is actually very standard, so typically we try to keep the water main as far away enough possible from the force main or reclaim main because we want to avoid contaminants. There's also typically standard set guidelines. So we happen to be in Florida, and FDEP, the Department of Environmental Protection, actually has specific code on the spacing required for these mains. Now typically FDEP wants 10 feet between the water main and any sort of wastewater main. Now, sometimes we can get to 6 feet, but FDEP says that they prefer 10 feet. So when we're actually laying out these utilities, the first thing that we ever do is just build a checklist of our constraints. Because the last thing you want to do is lay out these utilities wrong, because then you'll have to do it again. And you want to avoid any mistakes before actually constructing this stuff. So let's touch on a few important things here. So when we're connecting to this 12-inch water, it looks like we were already provided a stub. So when anyone ever says stub, that means that there was a portion of main actually stubbed out to you with a cap on it, and this becomes, an easier connection. They don't actually have to do a tap and sleeve, which is a whole deal. So again, it looks like what was previously built was a stub right here. And whenever you see this little triangle looking thing, that is a gate valve. A gate valve is what opens and closes the water main. So if that gate valve is closed, no water's gonna get through. If it's open, it goes through. Now, typically you will find gate valves around any sort of T's or the end of a pipe run. And again, in this case, there was a water main built up to this cap. This little symbol right here is a cap, means it's just capped and locked. No water can go through. And there was a gate valve placed right there adjacent to it. So the contractor, what they're gonna do is they're gonna come out, find that stub, and then continue that run. They'll remove the cap, they'll seal the connection with a joint, and they will build the water main. Now, one important thing here is that we called out a temporary water jumper meter. Now, again, every city, every county is completely different, and even the terminology is different. So in this case, a jumper meter is essentially just a backflow prevention device in this case, because the last thing we want to do is have water go back into the system, especially if we haven't certified it yet. So think of it as a protection device to not have any of the contaminants from the construction site go back into the system. Anything that comes into this main cannot go back out. Now, it'll be a temporary jumper or a temporary backflow because once the water main is completely built, we will then have to take bacteriological sample points, meaning people will actually have to go there, take samples of water, test it. We're gonna have to go through the whole certification process. We're gonna have to get as-built, and we're actually gonna have to certify this through the FDEP. Until then, we cannot remove this jumper until we actually get certification. So for more terminology, we also have something called reducers. So you might see what is called a reducer when you're reading utility plans, and you can't really see it because we got this text, but sometimes it's denoted as a little triangle. And all a reducer is just showing you where the pipe reduces. So this is going from a 12-inch pipe reducing down to an 8-inch. Now we're just gonna keep going along here because I'm gonna show you some typical things and then start diving into what to look for. So it looks like we've thrown in some bends over here. So this water main's coming here and then it's doing a 45-degree bend, 45-degree bend, 45-degree bend, and then another one. So it was obvious that we were avoiding some sort of structure here. Maybe it was a tree. I'm sure if we were to go on the other set of plans, maybe in the existing condition, site plan, grading plan, there's obviously something here that we're trying to avoid. And that's what we can do with bins. So we've talked about water mains a little bit. I mean, the only other thing on a water main that you have to watch out for are all the fire hydrants. Typically, fire hydrants have to be spaced according to whatever jurisdiction that you're in. But I wanted to make a quick note over here. So one of the things that you have to pay attention to when you're QA/QCing utility plans is how we are avoiding conflicts with structures. It goes back to those bins that I was talking about. So there is a storm structure here, guys, and you can see it kind of grayed out. So one of the important things that we have to do is make sure that when the contractor gets out there, we're not giving them a plan that shows a pipe going right through the box. That just doesn't work. Then you'll be getting a call from the contractor, and then you got to work some stuff out in the field. Right? So here we implemented 4 bins to actually bend this around the storm structure. And again, every jurisdiction is different, but standard practice is you want to at least try to keep 3 feet from any sort of structure. That's just a really good rule of thumb. I kind of want to touch on gate valves again. So gate valves are typically always at each T. So what is a T? A T is just a branch point. So here's the main line running down, and a T allows there to be a branch in the system. And typically we put gate valves on each side because think about it in terms of maintenance, okay? These mains and pipes will only last so long, and sometimes things might go wrong in the future. So we're trying to protect for the future event of a main shutting down and having to do work on it. So the only way to actually close this main down is to install gate valves. So look, if we have a gate valve right here, let's say there was a bust in the main somewhere over here, well, now we're able to shut down this gate valve right here, and that starts shutting down this main. Now what I will say is you got to keep traveling down because you got to go to the next gate valve. So let's say if they wanted to shut off, this line, we have another T right there. What the maintenance people will do is shut off these valves. They'll come turn those, and then they'll come turn that one. So again, gate valves have a purpose of being able to shut down pipe and maintain them for any sort of unforeseen circumstance. So that's just a little tidbit on gate valves. Now, again, I've already said this, but you'll find gate valves at the T, but you'll also find them typically either every 500 feet of linear pipe, 1,000, 2,000. It always depends on your county's design manual. And you also want to make sure that you never miss all of the gate valves that you need because you're going to keep getting comments from the county about that. And also, those gate valves aren't cheap. I mean, they can be thousands of dollars. So now I want to touch on services. So this is very common for a residential neighborhood is that you will see a water service and sanitary service and typically irrigation. And at least what these little water services are and irrigation services are just little whips. They call them whips. So if you're out in the field, the contractor might say they're a whip, but they're just little like HDPE pipes. They're kind of bendable, they're flexible, and they all have a meter. And that meter is placed right there, very close to the right-of-way line, because the utility authority is going to own everything up to that meter. They are charging you money based off how much water that you use. So that meter has a purpose. Now you own, as this homeowner, owns everything after the meter up to your home. And again, same with the double sewer service. So sometimes you'll see this. We happen to be on a corner lot. So this corner lot just has a single service. But if I keep going down, you'll notice that we have these little icons right here that shows a double service. And again, all this little double service is one connection, but it breaks off into 2 different little services with meters attached to them. You always want to be aware of how big these are, especially if you're dealing with any townhome project or commercial project. Sometimes they can be like 2 to 3 feet wide. It really depends on the meter box. So icons aren't always the exact size. So you have to take this with a grain of salt here. Now, typically with double sewer services or any sort of sanitary services, but these are little clean outs, and this is all gravity slope. So all of these sanitary sewer services are sloping down, 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 and then they're Ying This little break right here, this little 45 is a Y. So it's a Y connection into this gravity system. And again, this gravity system is using gravity to carry all of your wastewater down. Now, typically what I'm looking for in terms of conflicts is, let's say if you had utility mains all crossing over each other at exactly 3 feet down, well, those pipes are going to collide. So how do you avoid conflicts then? Well, you avoid conflicts by doing vertical bends. So we've already talked about these horizontal bends, but what about vertical bends? Vertical bends are ways in which we can dip pipe under each other. So, and I'll show you actually what that looks like. So if we go to a plan and profile, we typically show a profile of what that might look like. And here we happen to be bending our reclaim main under a water connection. So what this is showing here is a tee. A water is being teed off. So it's actually coming out of the page. It's out of the page into my face. And this reclaim main is dipping under it. Based from that profile, here's our tee. It's an 8-inch tee. And since this water main is breaking off this way, we will need to dip this reclaim main under that water mains. Now, one thing about bending pipes under each other is that typically we will never bend water under sanitary sewer or reclaim. Why? It goes back to those rules where we don't want to contaminate water. Let's say if there's a bust in the sanitary pipe or reclaim pipe, we don't want any of that water potentially going into the water main. So always be very cautious of the rules and regulations of your state. I think how I'll end this video is that I'll kind of walk through some of those details that we talked about just to show you what we're working with. I want to be able to show you that backflow prevention device that we were talking about in the very beginning. What we're looking at here is where we were connecting into. We had an existing pipe with a gate valve, right? And then a little stub right here, right? So this was our old pipe run. And here we had this little cap. This device that we've installed here is essentially a backflow prevention device. So when we're kicking off construction, the contractor is going to have to install this device temporarily so that water does not get backflowed into the system. Because like I said, we're going to have to certify this pipe before it can actually be connected here into the system. And always be cautious of how big these are, how big the pipe is, how big the backflow prevention devices, because your landscape architects will always give you a hard time. They definitely need to know where all of these are at so they can shade them from view, because sometimes they're big and ugly. Now let's go look at maybe some manholes. So this is a standard manhole. The standard manhole for this county is a 4-foot internal diameter manhole. Looks like we will be using PVC SDR 26. So that's the piping. So this is that gravity network that's flowing into our lift station. Always be very, very cautious of how deep you can go with your sanitary manhole. In this county, we can only go to 16 feet, which, remember we were talking about the sanitary sewer services and those little icons, right? Well, it's always good to know how big those actually are. So let's kind of look at this sanitary sewer detail. Up top, we have this plan view. This is the pipe that goes into the actual gravity main network. Here's the clean out that I talked about. So this is what that sanitary double service looks like. We have a clean out right here, and then we have these little bits right here, and this is directly at the right-of-way line, right? So, your home is somewhere over here, and the home builders are going to install the pipe leading up to this connection here. Now, what is a clean out? Well, a clean out is here in order to clean out any sort of buildup that happens. And there's actually a little machine that goes into here and can clean any of this out. Now let's go to the profile view. The profile view might help you understand how big the concrete collards are. This is what that clean out looks like. Last but not least, we talked about gate valves, and here's where I'll end it off. So this is the standard gate valve. It's always good to know how large this might be, and sometimes they'll give you the dimensions. It looks like 2 feet round concrete pad. And again, this thing is turned. There's a certain amount of turns that it takes, actual turns with the tool, to close and open this system. Well, guys, that's all I have for today. I hope you learned something new. I hope you're able to take away something from this video. And if you haven't already, please visit my land development series. I'm walking through an entire residential neighborhood project from the very start to the finish. I've also posted some links for some design spreadsheets and other resources. I hope to keep adding to that collection. Feel free to check those out. And like I said, if you haven't subscribed already and you've been watching my videos, just hit that subscribe button. It really helps me out. I'm looking forward to building this engineering community. If you want to drop some comments below on your name, if you're a student, young professional, I'm very interested to get to know you guys. Drop some comments below and I will answer all of them. Hope you guys have a good day, and I will see you in the next video. Peace.